Okay, this is an exam type question, but it's from the Platinum textbook. And somebody brought it to me and said, how do you do this? And I thought, hey, maybe other people should try this question. So let's just try it. Name four angles equal to 90 degrees. And it's always good to read all this stuff. You've got this P and Q and T and N, and they're all on the outside of the circle. You've got that this line here, NRM up to there, is a tangent. So there's a tangent going on. And important that this PON is a diameter, so that's a semicircle. So four angles that equal 90 degrees. Well, right up there, Q1's got to be 90 degrees, and the reason must be angles on a semicircle. And that makes Q3 90 degrees, angles in a straight line. But hey, I think that N3 must be 90, or N1 plus N2, PNO also must be 90 degrees, and N3 must be 90. That's because you've got a tangent. It's perpendicular to a radius. So there's the first one. You can do it in different orders, but Q1's 90 with the reason. MQM is 90 degrees, angles in a straight line right here, Q3. And PNM is equal to 90 degrees. PNM is equal to 90 degrees. Tangent is perpendicular radius. N3 is equal to 90 degrees, angles in a straight line. So 90, 90, 90, 90. There you go. Determine two other angles equal to x. How can we do this? Well, the trick to this one, I know that's 90 degrees right there. And if that's x, this angle here must be 90 minus x. And if that's 90 minus x, and that's 90, this triangle PQN, the only way that can be 180 is for N2 to be x. So N2 must be x. And oh man, T2 and N2 are opening up to the same segment, PQ. So T2 is x, angles in the same segment. Now, if you keep writing in all these things, like T2 is x there, you're going to look at the answer to the next question, because they say prove that MQTR is a quadrilateral, that you could put a circle through those points. Well, you can, because look, T2 is x and M is x. The exterior angle is equal to the opposite interior angle of this quad. That means it must be cyclic. So that's how you write it. MQTR is a cyclic quad. It's the converse of the exterior angle of a cyclic quad. You see M2 and M are both equal to X. And now a funny question that I don't think I've ever seen on an exam. Is PNRQ a cyclic quad? Well, PNRQ, would it be a cyclic quad? Well, the only way it could be, it's not a cyclic quad. And the only way, see if we drew a line right there. In fact, I think I wrote it in there. Well, if this is 90 degrees, the only way it can be a cyclic quad is if all these angles, Q1 and Q2, has to be 90 degrees. But it's not. So that's why it's not a cyclic quad. Because the exterior angle of the cyclic quad, the angles aren't equal. Well, you'll never get one like that, but there, that's the answer to that one. Okay.